In this video, I will be going over an application of the plant simulator using real-world data. The data was obtained from a study done by the state of Colorado about trees in the Colorado area. I chose 3 trees from the list: the silver maple, the red oak, and the red maple. And you can see that I have the centimeters per month growth data, and then I use that data and information about the trees to create the specific plant data to be put into the simulator. Just to go over each of the properties that a plant type has, each of them has a name, each of them has a color, which I based off of the description of the tree during the fall season because I like the fall colors. Each tree has an initial radius, which is the radius of the seed when it is placed into the simulator. It has a maximum radius, which is the largest that the tree can grow. It has a growth rate, which is an amount which is added to the radius each step of the simulation. Each plant also has a spawn rate, which is the likelihood each step that a new plant will be generated and start to grow. Each plant has a resilience, which is how likely a plant will be removed from the ecosystem if it has been taken over by another plant. When 2 plants collide, their vitality is compared, and if plant 1 has a higher vitality than plant 2, then plant 1 overtakes plant 2. However, plant 2's resilience is checked, and if plant 2 survives that being taken over, then it will live through one more cycle, at least one more cycle. And finally, the last number that can be set for each plant is the number of initial seedlings. At the beginning of a simulation, that many seedlings will be placed randomly throughout the ecosystem. For this next part, I am speeding up the video because basically I am just copying the data from the worksheet that I created and into my program. I'm choosing the colors that I think look nicest, and I'm just copying the data over. On a side note, I showed a friend this simulation, and I showed him with some of the default values with the bright blues and bright greens, and then I showed him this simulation, and he was like, "Wow, I really like those colors. They look very fall-like." And I was like, "Yeah, I did that on purpose." So I thought that was cool that he liked how it looked. Okay, so now I'm going to start the simulation with the 3 trees that have the real-world data, and we see them populating the ecosystem and interacting with each other. The final couple of things that I want to show about the program are that you can save the plant type definitions. So I'll pause it and I'll go ahead and save those. Save. By choosing File Save, it saves the definitions which are on the plant list on the left. So I'll name it Maples and Oak because I have 2 maple definitions and 1 oak definition. And I'll just give it a .txt extension. And so what I'll do is I'll delete a couple plants from the list on the left and show how that changed the simulation, that it in fact, if I delete plant with ID 1 and run it, then only 2 plants show up in the simulation. If I delete another plant and run it, then only the 1 plant will show up in the simulation. Finally, I can load the file that I saved. First I have to tell it that I know that I might lose information if I haven't saved, and then I load the file, and then all 3 definitions are loaded again, and if I run the simulation, there are all 3 trees that I previously defined and saved in the file loaded again into the program. And finally, I will show you that you can export the locations of all the plants in the simulation. So I'm calling this Maples and Oak Locations and saving it. And I will have one more supplementary video. So this is the official video for my submission, but there's one other video that shows two other features that I liked, and it shows one feature that I like, and it also shows the contents of the files that were created. Thanks for watching.